Do aspartic acid first, which isn't too bad. Our amino acid backbone. See why this comes in so handy now? Triangle. Let me think a second so I'm sure we get this right. Okay, not too low. The whole backbone will go across. So what's a backbone from nitrogen is simply a triangle. Got to get in the habit of making these bigger. N is bigger than C. So we got N to a diamond. No line in between it. This is the Schroeder diamond. Because see, there's another diamond over here to the carboxylate that we don't care too much about. Because it's the same every time. And what do we have? We got the double bonded O. And just write them in here. C, C. Up here is usually always a carbon off to the side. See, I'm drawing the diamonds bigger than the triangle. I shouldn't have done that, but we know. And all this has is a carboxylic acid on the end. So see, we're so experienced and well-weathered on this, even a carboxylic acid is nothing. And these are the most complicated amino acids there are with these carboxylic acids on the end of them. They're the ones people fear, and we're like, they're the ones we like. We get to color them in better. So we should even be making oxygen bigger, right? So what designates the carboxylic acid? Having the proton in the middle here. Almost all the chemistry that you're going to talk about that's acid-base is going to be the proton. So even though that would be an alcohol if it was by itself, technically it's a carboxylic acid there. But that's the proton that makes it an acid. What's on here? 2 H's, just a straight hydrocarbon, right? 1. Now it's not a continuous chain. So in this case, it's going to have the 2 H's here. That doesn't go anywhere there. This is the natural sweetener you hear about, right? So let's make this bigger. We'll even use a marker here. So the warning that you'll hear about, the next one we're going to do, the next one over here is phenylalanine. That's a neurotransmitter too. So if you drink too many sodas, it's got this sweetener in it. Some people have adverse reactions psychologically. We're going to have to draw the line here because we're mixed with that. But that's good because it'll separate it. That's aspartic acid right there. A side chain off the backbone with just 1 carbon with a carboxylic acid. Nothing more to it. We could color it in, but we're going to move ahead here. Make these diamonds smaller. Oh, and we don't even go to a diamond. We go to an N. Ugh. See, I should know this, huh? How can we fix this? It's just an NH, so it doesn't matter. Let's go. And we got to save room for the Schroeder diamond here, too. So let's go this way with it. See, I get talking and I'm not paying attention here. Here's the Schroeder diamond. That's the important one that's holding the side chain. Another diamond for the carboxylic acid side that is just a ketone in this part because it's got another side group on it. So instead of having the OH up there, we're going to get another side group, which is simply a methyl. So we're going to draw this a little bit smaller. Terminal methyl, it's on the end. So here we got to draw phenylalanine. Oh, and look, we already messed up the triangle. Oh, sorry, kids, we're really messing this up. All right, so get this up here. Diamond. And then just a benzene ring. So what do we got? Just one diamond, two diamonds, three diamonds, four diamonds, five diamonds, six diamonds. Let's see, we'll go double, single, single, double, single. So this will get a double and a single. So now we'll go through. These are all carbons. That's that benzene ring. Remember when they're on the side there, they each get a hydrogen on there. So let's draw our hydrogen. We can take a break here. If we're getting too far ahead of ourselves, let's color some of this in so we're not too intimidated. First thing I'm going to color in is this N here. See if we can make it look a little better. Let's use the whole marker. Okay, this is bigger too, so we can really cover up some of my little mistake there. So that bond is coming off this tip here, so if we can try and remember that. Let's draw out a dot with a line up to the triangle. Okay. So where is our crayons here? Start over here. Color in the carbons. Color in the carbons. Color in the carbons. Color in the carbons in all day. So listen to the mockingbird. So see how colorful this looks? And it's practical. It really lets you focus in on the functional side group. Okay, these are in. So again, I could prepare this and make it look perfect and snazzy and fancy and dandy, but I want you to see how I do it. When you make a mistake, how do you cover it? Everybody makes mistakes. It's how you deal with it. If you cover it up and lie about it, instead of coming clean and finding a solution. So again, here's the whole amino acid here. This should be real familiar by now. The backbone, nitrogen, carbon, carbon. That's got the O on it. This is the end. So the SchroederDiamond has the side here. One carbon with a carboxylic acid. That's the aspartic acid portion of this. Next, phenylalanine is just a benzene ring off a carbon. Do you see how simple these are becoming now? Let's come in this way to finish that off. So we got this would be a carboxylic acid on the side, but since there's a methyl group on there, it's missing that OH, so it's just got the double bonded O. That's called a ketone. Aldehyde if it's on the end of a chain. Okay, CH3, is that looking familiar now? So color that in. And again, you can color code the carbons because one that has 3 H's versus one that has 1 H or 2 H, they get different designations to the professor that likes testing people on this. But we're just having fun with it. Okay, so this is aspartame. I'm calling it ame. They probably call it aspartame. But we're thinking of the aim part, so we're calling it aspartame. Aspartic acid is where it gets its name. Okay, we were ready to color that carbon. Well, what do we do first? We check ourselves, make sure it's got the 4 bonds, so there's 2 H's. Oh man, we messed this up. See, that's why I had it right. This is supposed to go off that carbon. Darn it.